In this video, you will learn how to use a relay to switch on devices which are externally powered like motors and lights. So here we have a relay attached via 3 jumper leads to the Arduino board, and on the other side of the relay we have just 2 wires, one of which is connected directly to the power source and the other one has the electric load, in this case a motor, inserted into the positive line. And by using the relay connected to Arduino, we can control the motor by switching it on and off. Now, unlike MOSFETs, relays should not be used with PWM or pulse width modulation, because the switching itself is done by a solenoid inside the relay and is not designed for high frequency switching. So only use this for switching when the frequency of the switching on or off is more than 1 second, not less. So how do I connect this? Well, on the relay here, which is upside down, I admit, we have this side here connects to Arduino, and this side here connects to the power supply and electric load. There's my power supply, there's my electric load. So talking about this side first, we have the red there, the positive, connected to the 3.3 volt or 5 volt output socket here on the Arduino board. I also have the black cable here, the ground, connected to the ground on the Arduino port over here. Okay, and I've chosen Arduino socket number 7 on the digital side for my switching on and off, my signal switching, shown as the yellow cable here, going from the Arduino board going to the signal socket as shown in yellow here on the relay. Now let's talk about this side of the relay. This side connects to the motor or the load and power source. So we can see there's 3 terminals. Now it's important that at least one lead, say the one from the motor or the power source, goes to the center terminal. If you don't do that, nothing will work. And as for the 2 sides, at least one of these sides needs to be connected as well. In this case, I've chosen this side. Now, what's hidden beneath all these connections here are some symbols, some letters, abbreviations at the bottom of these 3 terminals. Anyway, this side has these abbreviation NO, which means normally open. The normally open terminal is equivalent to basically saying that my switch, I expect it to be normally in the off state most of the time. So if you're only going to turn on the switch every now and then, you probably connect the pin to here. On the other side, we have another abbreviation called NC. NC stands for normally closed, which means it's normally switched on. So if you intend that this circuit is going to be normally in the on state all the time, you'd have that pin over here. Now keep in mind, it doesn't matter if I have my, in this case, red means positive and negative means blue. It doesn't matter if I have my negative here or my positive going to the center, it doesn't matter. Okay, so I'm going to have my negative here instead of my positive, or my negative positive on this side over here, it doesn't matter. Okay, so the Arduino code will still run your motor or load in the same way. So let's have a look at how this is wired up. I've got it currently switched off. So I've got the lead. I've chosen that my negative from the power source is going straight to the relay, and then the positive in red is going to the relay via the motor. So and like always, whenever you have an inductive load like a motor, to prevent back EMF going back to the power supply or some other circuitry, I put a diode in parallel to my motor and with the opposite polarity to the current flow, the normal current flow when it's on. That will minimize back voltages which may damage other components, those back surge voltages. Let's turn this on now, and you'll see that when the light goes on, the motor's on. When the light goes off, the motor's off. Oh, the cable came loose. And here is the circuit diagram on Tinkercad. As you can see, we've got the same situation. Here's my relay, there's my diode, my motor, my power source, and Arduino. So a very simple layout.